Suppose we have a vector field given by this, and you're told that it's conservative with this potential function. Somewhere down the road, you may want to verify that by taking the gradient of little f and getting capital F, but you're given that information here. It says evaluate this vector line integral where C is the simple curve from here to here. Okay. By the way, simple here means the curve does not intersect itself. So, this is not a simple curve, whereas this is a simple curve. So, it's that usage of the word simple and not simple as in, straightforward or not complicated. Okay, so to do this, again, you might think, oh, I have to take this curve, I have to parameterize it, then I have to extract x, y, and z, got to find the derivatives, and then follow all these recipes. But the answer is nope. As long as the curve and the vector field satisfy the hypotheses here, then you can just use the theorem, and the vector line integral will equal the difference in the potential function at initial and terminal points. So let's see then if everything is satisfying the hypotheses, so we can use this theorem. So let's check. We have a conservative vector field. Yes, we do, we're told, with a potential function f. Great. Defined in an open domain D. We're not told what the domain is, but this is all of these components and this function itself are continuous, differentiable everywhere. So we can take whatever domain we'd like. C, the curve has to be piecewise smooth and oriented. So this is a point, this is a point. So the curve, quote unquote, between these 2 points, again, you could pick any curve, but we can think of it as a line segment. C is any curve. It has an initial point, it has a terminal point, so we're done with all the hypothesis checking, and we can now actually apply the result. So what is the result? The result is that integral over C of f dot dr equals f of b minus f of a. Great, and so we're doing f of the final point, 1, 2, 3, minus f of the initial points, -3, -2, -1. And then this is our function here. So we're doing 1 squared times 2 minus 1 times 3 squared plus 2 times y times z. And then we're subtracting -3 squared times y minus x times z squared plus 2 times y times z. Okay, so this is just a bunch of arithmetic to calculate. So we have 2 minus 9 plus 12, and then minus over here we have 9 times -2, that's -18. Let's see, plus 3, and then we have plus 4. Okay, so I've been known to make silly errors, especially most mathematicians actually, because we spend so much time thinking not in terms of numbers but in terms of other mathematical objects, make silly arithmetic mistakes. So I actually won't try to simplify this. I may have already made such a silly mistake in the last few calculations, but we'll say that I'm going to get some number here.